So, now we will see whether the number of lags can also change your estimates or not, right. So, we will first estimate the model without any restriction on the number of lag, and same model we will estimate by imposing by a restriction on number of lags to be used. So, what I will do again, I will be using xt upon 2 and then your in, and then I will be using the precise comma to specify my model in, and then L 1 by 2 dot n, and then L 0 by 2, or let us say this is, I will take only one period lag, 0 by 1 dot w, and then L 0 by 2 dot all the three variables k and ys. I am taking 2 periods lag for k and ys, then I have yr star, and then I have GMM, and within GMM I am taking L dot n only, L dot n, and IV style is within the IV I am taking L 0 by 1 dot w, and L 0 by 2 dot k and ys and yr star, and then I do not need level equation, I need robust, and I also need small sample correction. So, what I have specified then, xt upon 2, this is my dependent variable, I am taking 2 periods lag of employment, as in these are all after n, everything I am specifying as independent variables, 2 period lags of n, and then 1 period lag of w wage, then 2 period lags of k and ys, and then er dummy. Then I am considering again L dot n only as my GMM, okay, L dot n, and within IV I have taken first period lag of wage, 2 lags of k, ys and yr star. I do not need level equation because it is a difference GMM, and then I need robust standard error and small sample correction. With all this, what is my estimate? Sorry, I think made some mistake. So k, sorry, I need to put a bracket over here, okay. Within IV I have all this, right. Now this is my without restriction. What is the model I got? 0.68, okay, which is not lying within the interval. Then what we will do? We will now impose restrictions on the lags to be used, okay. How to do that? The command is again xt_2 and then in xt_2, then I will be taking in and then in L1 and in L2 okay, in L1 in L2 and then W and WL1 and capital first and second leg of capital YS and then I have YSL1 and YSL2 okay, and then I have dummy. Sorry, I have dummy. So after that, when I put the GMM, my GMM is in L1 only, in L1, then I am taking only lag 2 to 5. So, I am restricting the lag up to 5 instead of going up to 8. Earlier as I showed, it was taking up to 8. So, this is lag I am specifying 2 to 5 and then my IV are same as W and then WL1 and capital and then capital KL1, KL2 and then I have YS and then YSL1, YSL2 and YR star and I do not need level equation, no level, then robust and small. Now, one question may come to your mind, look here I am specifying the lag for the endogenous variable, but I am not specifying any lag for the IV style variables. Why? Because it is not required actually. If you recall that exogenous or predetermined variables are considered they themselves are considered their instruments. So, there is no need, the moment you put the variables within the bracket of IV, it is assumed that these variables are either exogenous strictly or predetermined and the appropriate lag, if it is not lag then first order lag, if it is difference then the same variable will act as their instrument. So, while for endogenous variable it is the lag from second to higher, whatever is available they are used as instrument. For exogenous and predetermined variable we do not have to specify any lag. That means imposition of lag length is redundant within the IV bracket because they themselves are considered as their instrument. So, lag length restriction is valid only for GMM. Now, if we put that, now see what is happening. So, the coefficient in L1 which was 0.68 earlier, not lying within the theoretically determined bound. Now, you have achieved a miracle by restricting the lag up to 5. Now, this is coming out to be 0.83, which is perfectly lying within the interval. So, that means we have proved one thing, that restriction of number of lags. So, basically what we have proved, that number of lags, lag restriction alters the estimated coefficient drastically. Okay. With no restriction, while the estimated coefficient was lying beyond the interval, with restriction imposed, it is lying within the interval. Then you might be thinking, instead of restricting the lag, why not reducing the lag to 4? What will happen? So, let us see, if we reduce the lag to 4 instead of 5, what happens? So, here what we will do, instead of, sorry, not this one, we will be, yeah. So, instead of 2 and 5, let us see what happens if we put 4. So, that means we are keeping everything else same, we are just reducing the lag from 5 to 4. See, the coefficient of NL1, again it is going beyond the interval. What happens if we reduce the lag to 3? Again, so that means again it is going 1.10, and here also it is 1.010. So, that means instead of 5, the moment we use 4 and 3, then it is not working well. So, with this you can understand, that means in this particular situation, maybe lag length 5 is optimum, we have to go with 5 years lag. So, that we are able to estimate, right. So, reducing lag, so number of lags of the lag dependent variable. So, this implies that lag length of 5 is optimal, because if we use lag length as 4 or 3, then coefficient of NL1 is going beyond the limit. Okay. Now, what will happen if we use, instead of using instead of estimating a difference GMM, what will happen if we put a system GMM? So, two-step system GMM. So, we are restricting the lag. again it is coming down to 0.63, right. So, that means when you are restricting the lag to 5 while difference GMM ensured the coefficient to lie within the interval, the system GMM could not. And if we do not do all these things, if we do not put any restriction, then what is happening? Let us remove the restriction. Again it is going beyond. So, that means if we put no cons, none of this system GMM model could ensure my coefficient to lie within the interval, right. You may think that I will change the lag length to 4, what will happen? So, when I put 4, the coefficient is lying again beyond the interval. So, what I need is 0.73, but it is coming out to be 0.55. So, the same problem, probably the only solution here, what we have to do is if I remove this YS, now I am considering only this, there is no industrial output and I am again going back to same command, that means I am restricting the lag and then let us see. So, this model is basically saying all else is same and then I have removed only the industrial output as a proxy for demand as an explanatory variable. It is lying again, it is coming down 0.37. So, even that is also not working. So, if I remove NL2, I will consider only one period lag, then what happens? Now, this model is working fine. So, what is the specification that means I have used? Look at the specification. What is the specification? That is, I have taken only NL1 as the one period lag of employment only in my model. I have taken W and then I have taken lag of W, I have taken 2 periods lag of capital, only this many explanatory variables and then restriction of lag also to 5 and then my coefficient is lying within the interval, right. So, that is the modification I have to make, but this model when I remove YS, if I remove this lag length also, what happens? That means, now in this model I have neither considered YS, which is basically the proxy for industrial output, nor I have given any lag restriction on this. Okay. What happens in that context? So, even without restriction also it is coming out to be 0.91, with restriction also it is 9112, this is also 9141, little change in the coefficient, coefficients are all significant and then I have other post estimation checkup like AR1 is there, AR2 is not there, that is satisfied here. So, basically what happens in this case, without any restriction on lag length and with restriction on the lag length, both are giving almost same result. When my model is only considering NL1, that means 1 period lag of the employment, but I have removed the WYS from the model, industrial output. Okay. Without any restriction, I have achieved this. Okay. And if I bring in YS, then you can understand what will happen here. So, I will put YS, industrial output, and then within the GA also this is, sorry, earlier model I think we made some mistake. See, we have not considered YS here, but we are considering YS there. So, that was the mistake. So, let us now remove that and see if we get any changes in the estimate. So, what we are estimating? We are putting restriction on lag length up to 5, but my dependent variable is N and only 1 period lag, there is no YS. So, that is the only modification, and then I am using system GMM, robust standard error, small sample correction, that is the thing. So, we are imposing restriction on the lag length within the system GMM, but we have removed YS and we have removed NL2, only considering first period lag. So, we have made some mistake over here. So, this is the model. Okay. And sorry, where is my lag? Yes, this is my lag length model. There is no YS, so I will just remove the YS. Yeah. So, now what is happening? Fantastic. So, now when I remove YS and put restriction on lag length, then also I am getting NL1, which is 0.93. So, this is how, if you want to learn the models, you need to play around with different model specification. Sometimes you impose restriction on the lags, estimate difference GMM, then you estimate the same difference GMM without restriction, you estimate system GMM with restriction, system GMM without restriction, you use only 1 period lag of employment, you use 2 periods lag of employment, and see with different alternative structure of your model specification what type of results you are getting. So, here what is the model I have estimated? I have given a restriction lag length up to 2, up to 5, and I have removed this YS. Okay. Now, in this model, if I include YS also, what happened? YS, YS1, sorry, YSL1 and YSL2. Now, I am considering once again industrial output, but I am just removing the restriction on lag length. And I am considering NL1 only as my endogenous variable. And here also I have to put ys L1, ys L2, and then I do not require level equation, I have removed level. This is a system GMM, 2-step, robust, small. Again that is 0.93. So, what is the difference between these two? Here I have considered only 1 period lag of employment, wage 1 period lag, capital 2 periods lag, ys and its 2 periods lag, everything I have considered, but I have made only one change. I have not put any restriction on my lag. So, that is why if you come down, you see again it is lag of 1 to 8 is considered as that optimum lag length. And if you do so, then you are again once again able to achieve the coefficients to lie within the interval, right. And this specification, lastly once again what we will do, we will put all these and then we will put only here ys L1 and ys L2. Now, we are considering this also, and then once again within here ys L1, ys L2, and then what is happening? Again it is lying within the interval. Okay. So, I have considered everything here, NL1, W, WN1, K, KL1, KL2, YS, YSL1, YSL2, everything I have considered. I have imposed lag length also, but I have considered only NL1 as endogenous variable and I have not considered second period lag of employment, that is not required. Okay. So, your model specification, that means when you play around several model specification, you must ensure one thing, that your estimates of the lag dependent variable NL1 is lying within the interval. If that is achieved, then we have to see other aspects of the model, that means whether the post estimation checkups like AR1 is there or not, AR2 is there or not, so on and so forth. So, with this we are going to close our today's discussion, and before we close, we would like to summarize what we have learned so far today. We have learned one important thing is that model specification plays an important role on your quality of the estimates. And when you are particularly interested in dynamic panel, please keep in mind that when I say quality of the estimates, that means we need to check whether my estimate is lying within the interval or not. How will you get those intervals? You estimate the model by FE, you estimate the model with OLS, while OLS will give you upper limit, FE will give you a lower limit, and then you come and estimate your dynamic model and see whether that is lying within the interval, right. And these estimates, they are quite sensitive to model specification. And what is the model specification we are talking about? Which variable you are going to consider as endogenous? How many lag of the endogenous variable you are considering? And how many lags of the instruments while determining the GMM style instrument, how many lags you are using, that is all, right. So, by changing the specification of my GMM style and IV style variables, what we showed today, that the coefficients, estimates of your coefficients, they change drastically. So, which specification you will use? First of all, you need to read your theory, you need to understand the context, which variable is endogenous and which is exogenous. If your theory says that wage and capital also should be considered as endogenous, there is enough reason to believe that wage and capital cannot be considered as exogenous, as in the case here there is joint determination between wage and labor supply, and there is a reverse causality from employment to capital. That means it ensures these variables also to be considered as endogenous. That means they must enter within the GMM bracket. If you enter that, then you need to specify how many lags you are going to use. First, try your model without any specification on the lag and see whether you are able to get your estimates lying within the interval. If it lies, well and good. If it doesn't, then you play around with changing the lag. You impose lag restriction. So, these are several ways by which you can get alternative specification to ensure that ultimately the estimates of your dynamic panel data model, particularly the estimated coefficient of the lag dependent variable, is lying within the interval. With this, we are closing our today's discussion. Thank you.